Hello, I am Trishan Banik from second year EC department, and today I am going to present a very fundamental topic from the subject signal and system, and that is classification of signals. I have categorized it into 5 different types of classification. Before coming into the types of signals, at first understand what is signal. Signal may be a function of time, temperature, position, pressure, distance, or any other physical quantities. So, at first, come into the continuity type of signals, continuous time signals, and discrete time signals. A signal which is defined for every instant of time is called continuous time signal, and a signal which is defined at only some discrete time intervals like integers is called discrete time signals. You can see in the graph that in the graph A I have drawn a sine wave, and it is an example of continuous time signal. In the graph B I have drawn an example of discrete time signals. Now, periodicity. Periodic signal. A signal that repeats after a fixed time period is called periodic signal. Let's assume the time period is capital T. So, if the signal is a function of t, then x small t is equals to x small t plus capital T, that is time period. This is the condition of a periodic signal. As an example, you can say sine 2 pi ft is an example of periodic signal. Or in the real world example, AC voltage waveform is an example of periodic signal. A periodic signal. A signal that doesn't repeat over time is called a periodic signal. In real world example, speech, one single music note is an example of a periodic signal. Now, this both type of signal, periodic and aperiodic, can be further categorized into continuous and discrete time signals. So now we have 4 types of periodicity type of signal. Periodic discrete signal. As you can see in the graph number 1, I have shown an example of periodic discrete signal. Like that, a periodic continuous signal in 2, a periodic continuous signal in 3, and a periodic discrete signal in 4. So you can clearly understand by seeing the difference in the graph. Determinism. Deterministic signals. This type of signals can be completely specified by a mathematical equation. So we can easily determine this type of signals like ramp, impulse, and in the graph I have shown a sine wave type of signals. Non-deterministic signals. This type of signals exhibit unpredictable behavior. Their values are random in nature. And you can see in the graph, you cannot predict the next part of the signal. It is totally random. Now, energy signal. Energy signal is one which has finite energy and zero average power. If x is a function of t is an energy of signal, then E is greater than 0 and less than infinity, and P is equals to 0. Then the equation of energy signal is the integration of xt whole square multiplied by dt, and the limit will be from minus infinity to plus infinity. In the case of discrete time, we have to use summation sign. And in the graph, you can see the example of energy signal. It is an example of decreasing exponential signal. So now power signal. Power signal is one which has finite average power and infinite energy. So the equation is P equals to limit t tends to infinity 1 by 2t integration xt mod square dt. It is for continuous time, and if we are into discrete times, the integration time will change into summation and t changes into n. And you can also see the graph which I have drawn. So there are some signals which is neither energy nor power signals. This type of signals have infinite energy and zero average power. Example, linearly increasing ramp signals. Symmetry. We can divide signals into two parts or into two types by symmetry. Even signals or symmetric signals, odd signals or asymmetric signals. A signal which is symmetric about its vertical axis is called even signals. Here we have to follow a condition. X of t is equals to x of minus t. Cos t is an example of even signal. Then odd signal. A signal which is asymmetric about its vertical axis is called odd signal. Here the condition is xt is equals to minus x of minus t. Sin t is an example of odd signal. Now further I have discussed about more two types of signals, and that is analog signal and discrete signal. Analog signals are continuous waveform that repeats data as a range of values, while digital signals are discrete, representing data as a series of distinct values, typically binary 0 and 1. So you can see the graph and clearly differentiate between the analog signal and the digital signal. And now this is the end of my presentation.